So now we can go over these. So if we start here with ibuprofen, over here we have a carbonyl bonded to an OH group, and that is known as a carboxylic acid. And we also find a carboxylic acid in our second molecule over here, tyrosine. In addition to that, each molecule contains an aromatic ring. Now for ibuprofen, that's it. Some of you may, this is something I see early on, is that students will label alkanes. But given that virtually every molecule has some sort of CH and CC single bonds in it, we don't usually label alkanes. Tyrosine has two more though. We have the carbon bonded to an OH. That's an alcohol. And over here, the NH2 group is an amine. All right, we can move to our next group of molecules. So the first thing we might notice is we have a whole bunch of alcohols here in glucose. And glucose also has this carbonyl. This carbonyl has a carbon on one side and a hydrogen that's not drawn in on the other side, which makes it an aldehyde. Cysteine here, as well as naproxen, both have carboxylic acids. Cysteine also has an amine. And a thiol. Whereas naproxen has an aromatic ring. And up at the top here it has a carbon bonded to an oxygen bonded to a carbon for an ether. Now let's get to our two complicated molecules. So we can start over here on the right with betanin. Betanin is the compound that actually gives beets their color. And so we can start out, we have a pair of carboxylic acids. Here we have an amine. We have two alkenes, the carbon-carbon double bond. Over here, as well as all around this ring, we have alcohols. Here, or we could go this direction as well, but we could see the ethers there, the carbon, oxygen, carbon. And finally, over here we have an aromatic ring. Now, you might notice we've kind of ignored this carbon-nitrogen double bond as well as this thing that looks kind of like a carboxylic acid. And that's because those are functional groups. It's just that they're different from any functional groups that we've learned. So right now we're not going to worry about their names. Finally, we have Taxol, which we can see is a very large molecule and has a lot of different functional groups in it. So first, we've got 3 aromatic rings. Then I'm just going to sort of work from left to right. So here is a carbonyl that's also bonded to a nitrogen, known as an amide. We have some alcohols, one here, and a third one over here. Up here at the top, we have a carbonyl bonded to an oxygen, bonded to another carbon, which is an ester. There's also an ester here, as well as one here. Over in this part of the molecule, we have a carbon bonded to an oxygen, bonded to another carbon. That would be an ether. Right here in the middle is a carbonyl that's bonded to 2 carbons, which is a ketone. And finally, we have a carbon-carbon double bond here, or an alkene. So a lot of functional groups in this molecule, but it's really just a process of going through one by one and finding what's there.